Hello and welcome back to Advent of Code 2023, day 16. Sorry, my kettle is making a bit of noise. So as you can see, when I first saw this weird numbering, I thought the site was glitched or something, but it turns out it's supposed to be like this. So it's like we're the elves and we're going across the islands in this direction. And we got what we came for, which was whatever we got in 14. What did we get in 14? Oh, the parabolic reflector dish. We positioned it. And now we simply making our way back. So that's why the numbering goes a bit weird. There was one year which did this before, and that was 2020. See, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then you kind of go back, and then you go back down. So it's, oh, you can see the path there, look. It goes down and up and down. Not quite as irregular as that, but that's cool. It's fun. It's like a little RPG adventure. All right, 16. All right, I'll just open the page and I'll go get my coffee. The floor will be lava. Ooh, wonderful. More 2D maps. This looks a bit complex. Okay. Right. So, the floor will be lava. Is this because we've now heated up the lava and it's going to overflow or something? With the beam of light completely focused somewhere, somewhere. Oh, this is one of the hover texts that you get when you complete all the puzzles. Alright, the reindeer leads you deeper still into the lava production facility. At some point you realize that the steel facility walls have been replaced with cave, and the doorways are just cave, and the floor is cave, and you're pretty sure this is actually just a giant cave. Finally, as you approach what must be the heart of the mountain, you see a bright light in a cavern up ahead. There you discover that the beam of light you so carefully focused is emerging from the cavern wall closest to the facility and pouring all of its energy into a contraption on the opposite side. Upon closer inspection, the contraption appears to be a flat, two-dimensional grid square containing empty space, mirrors, and splitters. The contraption is aligned so that most of the beam bounces around the grid, but each tile on the grid converts some of the beam's light into heat to melt the rock in the cavern. You note the layout of the contraption. Right. The beam enters in the top left corner from the left and heading to the right. Then its behavior depends on what it encounters as it moves. If the beam encounters empty space, it continues. If the beam encounters a mirror, the beam is reflected 90 degrees depending on the angle of the mirror. Okay, that's intuitive enough. Yep, I get it. If the beam encounters the pointy end of a splitter, the beam passes through the splitter as if the splitter were empty space. Okay. If the beam encounters the flat side of a splitter, the beam is split into 2 beams going in each of the 2 directions. Oh dear, okay. Interesting. So at some point you're actually keeping, if you're following where the beam goes, you're actually following the paths of several beams. An indeterminate number of beams that could increase. For instance, a rightward moving beam that encounters a splitter would split into 2 beams, one that continues upward from the splitter's column, and one that continues downward from the splitter's column. Yeah, okay. Beams do not interact with other beams. The tile is energized if that tile has at least 1 beam passing through it. Alright, so, okay, that looks complicated, but that's just describing where the beam's going. And then you end up... and they go off the side of the map, I suppose. How many tiles end up being energized? Okay. So it's tricky coding, but algorithmically it's not hard. I think we just keep track of the beam, and for each beam well, we can do the beams independently. You could even parallel process this, but we don't need to do that because they don't interact with each other in any way. So yeah, okay. Yeah. Okay. So, as usual, we've got to start by just putting together a 2D grid. Got our input. Which we'll store as a list of strings, as we usually do. Grid.append line.strip. Okay. All right. Beams. So for a beam of light, we have a current position and a direction. The directions are only north, south, east, west. This time, should we actually create a pause? I mean, I should have done this in several problems before, but I just didn't. Let's do it. That way we can do addition. So class pause. So define init. Oh, we can make this, can try using the decorator. Static class? Static, no. We want a data classes? Is this appropriate for... It's not really a data class because we want... What exactly are you allowed to do with Python data classes? Let me have a quick look. Okay. So if you do that, then you don't need an init. We can do X, or no, let's say row, which is an int, and column, which is an int. That's all you have to do. Define add so you want row equals self dot row plus other dot row, column equals self dot column plus other dot column. Do we need anything else? Hashing, I guess, because we want to create a set of all energized. So we need equal. So it's going to be like this. Just check that these match. And then we would do just this. Okay, those are the classic methods we need. Add is the important one to begin with. Data classes is not callable. I'm not trying to call it. What do you mean? Oh, wait. Why is it classes? Data class. There we go. Just... There we go. Is that all we need to do? Okay, so what's this? Overrides method in object. Ah, I think they give us this for free. Let's see. Pause 1, 2 equals pause 1, 2. We don't need to define hash, they know how to do it. Oh yeah, of course, that's one of the great things about data classes. Okay, nice. Add? Do we even need to... Yeah, we do need to find add. Alright. So. Beams equals... So... there is going to be a single beam. It starts off at row 0, column -1. That's off the grid, but that's fine. This is conceptual. And it has a direction of 1 in the column value. So it's going towards the right. So that tuple describes a beam and where it's currently located. And basically, my idea is beams, as long as there are beams. Alright, so energized equals set. That's where we're going to put all the energized cells. While beams. Okay, so while there are still beams that are unresolved, a beam becomes resolved when it goes off the edge of the map. Right? So while there are beams, we pop off the beam in the final position. I'm just wondering, could this get into an infinite loop? Good. It could. It could. Okay, hang on. So, we need to clear all beams that we've processed before. So the moment we process a beam to get its sub-beams after one movement, we need to put that beam tuple into cleared to make sure we never process it again. Otherwise, you can actually construct, say, a vertical, a horizontal splitter, a vertical splitter, and a horizontal splitter such that pretty sure you can construct an infinite loop here, so we need to actually do this. I bet there's something in here to trap us. Alright. Because we only care about energized cells, so it doesn't matter if how many beams go through a cell, as long as we've done it once, at least once. Okay, so while beams. Pause direction equals beams.pop. So we've got a position, we've got a direction. Next pause equals pause plus direction. Alright, so we've got a next position. Also, the moment we do this, so we do that so that we never deal with this again. Next pause equals if not so we want 0 is less than or equal to next pause dot row is less than or equal to m equals length grid length grid 0. Class int. Int. It's 1 int, 2 ints. That's a pause, that's a direction, that's a pause. We'll see what happens, I guess. Also, why have I not? That should be tuple. I don't know what the problem is here. Right, if it's not within the grid, it's gone off the chart. Even though we started off the chart, but that's fine. if it goes off the chart, that means it just goes into empty space, so we don't need to do anything more. Tuple has no object row. Next pause equals pause plus direction. Ah! These are not pauses. Also, is this the right order? Yeah, okay. Unhashable type pause. Unhashable type pause. Well, I thought we dealt with this. But we didn't have to do this. Okay. Overrides method and object. Yeah, well... we need to define equality as well. I guess, what is it hashing then? I guess it's just hashing the memory location. By default, I assumed... that data class would... No, it makes sense, because you might have floating point numbers, which can't really be... it wouldn't make sense to put them in the hash, so... Alright, I'm having a look at the documentation. Hash... hang on, equal. If true, an equal method will be generated. Tuple of its fields in order. Nice, we can do that. Eq equals true. So you have to do this. Alright. Then we don't have to define equals. It just does a tuple of its... and then unsafe. So we've got... init is true by default. Rep is true by default. Iq is true by default. We don't even need to do iq equals true. Okay, unsafe hash. If false is generated according to how eq and frozen are set. Alright, I think we want to do this. Unsafe hash equals true. Try that. Well, let me have a quick read of this. I'm learning stuff about this data class. So unsafe hash. So if we leave it false, which is default, then a hash is generated according to how eq and frozen are set. So if frozen... Oh, we can do frozen to make it immutable. Frozen means the moment we've set it, it can never be changed. That's what we want. We want pos to be immutable. And if I do that, then I believe it auto creates a hash. There we go. So we don't need to define a hash. We don't need to set unsafe hash equals true because it's safe hash now. Frozen is set, so it's safe for it to just use a tuple of its values because it knows you'll never change it. So, yeah. Alright, this is taking me a while, but I'm learning about data class, so that's good. Okay, so that's pos. That's much simpler than how I usually write it, because we're using data class, so that's pretty good. Alright, so where are we? So we pulled out a beam from our list of beams. We found where it's about to go. And now we need to work out what happens to this beam. Well, we know where it ends up. It ends up in next pos. We just need to work out the direction it's gonna, the new direction it's gonna have. It may have two. Okay. Let's handle the cases then. R equals grid. So we want the row, so it's going to be next pos dot row, next pos dot grid. All right. All right. Let's start with the mirrors. So if it's a forward slash, well, it's going to be like this. It's going to go pos. So if it's going right, then that gets mapped to going up. It's wrong. -1, 0. If it's going down, this is so confusing. This gets mapped to left. If it's going up, this gets mapped to right. If it's going left, this gets mapped to down. You could use matrix. No, well, no, it wouldn't. It's not. We're not rotating. But at least it depends. Okay, yeah, writing it out explicitly like this is probably best. Okay. So new direction equals yeah. So it's going to be that. Alright, I might need to zoom out a bit just because this is a bit... Okay, so if it's backslash... Oh, it's gonna have to be like this. So, okay, this is different. So, hang on, so if it's backslash, so if we're going right, we end up down. If we're going down, we end up right. So it's basically the negative of everything before, is it? Let's just go through one by one. Check we got it right the first time. If it's going up, we end up going left. If it's going left, we end up going up. Yeah. Alright, so the other... Oh yeah. The basic one is... Hello, Hereford Bull. Just working on day 16. I think this here is the trickiest bit, just translating all these symbols to meaning, direction changes. But once I've got that, I think the rest of the method is straightforward. It's messy to code, but it's not. I don't think it's hard yet. Part 1 is just tracing the path of a light beam. So whenever you hit a /, say, from the left, it bounces off and goes up. So you basically just gotta code all the cases. So I've handled the slashes. Now I've got to handle the vertical and horizontal. So this one. Alright, so if it's... minus sign. Alright, the two cases. If we are coming horizontally, then we treat it as if it's a dot. So we just go straight through it. So if direction dot call. Hang on, so dot row is 0. That means we're going horizontally in one row. New directions dot append direction. Else that means we're going, if it otherwise we're going vertically. That means we have to add 2 directions. The beam splits. So at this point we end up with 2 beams. One going left. One going right. Okay. Elif car is... This is the only final case, but I'll code it out explicitly anyway, so let's say vertical pipe. Alright, so if the column is 0, that means we're going vertically. So that's fine. We just maintain the same direction. Otherwise, we go 1, 0, minus 1, 0. We get split. That's all symbols, right? Alright, so by the end of this kind of ugly process, we should new directions has 1 or 2 directions. 1 means the beam has just changed direction or not changed direction. And if there's 2, that means the beam split and each new beam has a direction. Either way, for U in U directions. If so, it's going to be I should say next directions. Refactor. Rename, just to be consistent here. Let's call it already done, be more explicit. Alright, so if it's not already done, this is a new beam of light. So we put it into the beams. Alright, and then finally, we want to just energize every next pause. That's where a beam enters. Alright, this is quite complicated for part 1. Alright, and then should we just run it and see if it actually... Next pause.row, next pause.call. Oops. That should be less than, that should be less than. Okay, it finishes. Alright, well, ultimately, what did they want us to compute? Just the number of energized tiles, so... Don't debug. 7959? Nope, too high. I'm always getting it wrong first try. Even for part 1. Top left. Oh wait. Top left means... No, that's fine. Enters in the top left corner from the left. Heading to the right. And the top left corner is... Oh. Wait, what do they actually mean by in the top left corner? They mean it doesn't matter what that symbol is in the top left corner. The light beam ignores that and is heading to the right from the top left cell. I think so, yeah. In that case, yeah, we need to slightly modify it. What we need is... So it's actually 0, 0. And... yeah, it's going to the right. Is the first cell energized? Yeah, by default it's energized, okay. So... oh yeah, you can do it like that, okay. 128. Suddenly we drop down to 128. That was a massive drop. So if we were to enter, I guess it's a completely different path now. If we would go there... 128? Well, did they say we were too high? Now we're too low. Damn it. Alright, well, is that closer or further? I think this is more correct now. Beams equals... so its position is 0, 0, and its heading is to the right. We've energized 0, 0. Already done. I suppose technically we... no, we don't add anything yet. Well, we... So if it goes out of bounds, we continue. So eventually all beams will eventually hit, go out of bounds. One, two, eight. All right, fine. We'll try the example. No, that's not the example. 52. Should be 46. We're gonna have to print a visual representation now. Or for now, let's print energized. Yeah, can't make much sense of that. We're gonna have to print it visually. Alright. V equals, let's say, okay, we want to match, okay, let's say dot for so we want pos dot row pos dot col equals hash, and then finally for row in G print dot join row. Okay, this should print it visually. Whoop. G pos dot row what's going on here? I think we've got some invalid. I think we're energizing. Oh, I know what the problem is. I know what the problem is. We're energized. That energizing should come after the out of bounds check. So we're actually energizing some extra cells. In fact, we're energizing for every beam that leaves the grid. We're energizing one of the cells outside of the grid. So should get, yeah, 46. There we go. And look, there's a visual representation that does match. Okay. All right. Let's not bother printing. One, two, five. So there were only 3 extra beams, extra cells energized. Okay, 1, 2, 5. No, that's slower. What the? So that's even lower. Okay, that was a bug nonetheless. So we've got it correct for got it correct for the sample, but I'm too low for this one. This is really weird because we start on that that backslash. But the sample they had didn't have a backslash in the first space. So what actually enters in the top of... So it's actually not... I feel like the description is slightly ambiguous here because the sample had an empty space for the first cell, in which case the beam just goes through. But the input has a backslash for the first cell. Are we supposed to ignore that? Because it says... Right, the beam enters in the top left corner from the left and heading to the right. that doesn't... Does it mean it's heading to the right as it enters, or heading to the right after it's entered? I would argue that's ambiguous. No, you can't ignore that. So that sentence means heading to the right just before it's entered. And when it's entered, you now have to resolve where it's heading. Fine, I can do that. I'm not happy with that sentence, though. I think there's two ways you could interpret that. Although I think I had the right interpretation to begin with, and then I changed it. So, okay. So it turns from going... Okay, I can fix that then. So... we start off the grid then. Start from negative... where did I do this? So we start from -1, off the grid, going to the right. We don't energize anything. And then the first cell we enter, it will then process the mirror. It will energize that cell. Okay, let's try that. 7860. Now we're back into the thousands, but maybe this is correct now because I fixed the other bug. I mean, it makes sense that the number would be in the thousands and not as small as 120 something. Okay, that's fine. It would take me about 20 business days to do this using ChatGPT. I haven't tried, like, there was a couple of years where I tried using ChatGPT afterwards, just to kind of see if it was actually able to solve it. And, yeah, but in most cases it did just from me pasting the entire description in. It just gave the right answer. But then it's not a fair test because it might have trained on other people teaching it because they were also doing the same thing, so it's not easy to judge whether it's actually working it out or it's just copying from what it learned from other people pasting in. I don't want to touch ChatGPT this year because I don't want to feed it with information until the whole competition's over. So I won't be doing that this year. But I mean, from my experience, it was good, but then, yeah, as I say, it's not a fair test because that was years. Those were archived years, so it probably learned. Yeah, I think the only way to test for sure right now would be to try on each of these questions and see if it gets it right, which I haven't done, and I don't really want to do. I don't want to let it learn right now and then have other people be able to use it. Well, it doesn't matter because the leaderboard will be over by that point. I don't know. I guess it's fine. I'm too lazy though. Alright, part 2. As you try to work out what might be wrong, the reindeer tugs on your shirt and leads you to a nearby control panel. There, a collection of buttons lets you align the contraptions so that the beam enters from any edge tile and heading away from that edge. Okay. You can choose either of 2 directions. Okay, fine. Corners. So yeah, from each full edge, you can enter from that edge. Okay. So the beam could start... Oh, is that it? Okay, this is easy. Just for loop over every starting position. Configuration that energizes as many tiles as possible. So we get Okay, let's wrap this up as a method, which gets the number of energized cells for a given start and direction. Oh, nice easy part 2. This approach can be a bit slow. How slow are we talking? So it's going to be... So, like, in worst case, a beam could go all over the place. So let's say it covers every cell. So it's going to be quadratic time multiplied by linear time. So basically cubic time in one of these widths. Yeah, it's plain text is not dark mode friendly. Well, at least there's probably a way to make this work in the browser. I don't know. I haven't figured that out. So it'll be cubic time. I think that's fine for whatever n and m are. Should we print n and m as well? I want to know what kind of size we're dealing with here. $110. Oh, that's so basically we'll be like in the tens of millions. Okay. I think it'll work fine. Because I'm not going to get stuck in any cycles because I'm kind of caching. Because you can construct infinite cycles here, but yeah, I'm making sure I've got this already done thing. Okay, so let's wrap this up as a method. So define get num energized. So for a given position and direction, that's the starting position of the light beam and the direction it's traveling in. So beams, okay, let's just take that out for now. Beams equals, so it's going to be that. Energized equals set. So everything else is as normal. And ultimately we return just length of energized and let the garbage collector deal with that. Or not, who cares? We can just use lots of space in Python. So part 1 is just print get num energized. Let's make sure we still get the right answer here. So it's going to be pause 0 minus 1, pause 0 1 as before. Yeah. All right, let's check we've got that right. Oops, why did forgot to write return. 7860 was that? Yeah, okay. What is a nice quick way of... All right, let's just do this. Starts. So these are all the starting positions of the beams, positions and directions. Just a list. So let's just go through all the different. So for I in range n. So for each row, let's do the beam from the left and the beam from the right. So start, stop, append. So it's going to be pos I -1, and then the right and direction, and then pos I, so it's going to be M going left, right, and then just same thing, J in range M, so starting from -1 in. Hello, Amaro. Have you had a look at today's problem? I think I'm almost done. And then from the top, we're going down. Wait. J. Oops. So it should always be J here. Hang on. Oops, I've got all these wrong. Looks fun for GML. Yeah, I mean the input's not too big. It's about 100 by 100, so you can simulate it. You just gotta make sure to destroy things once they leave the grid. You can get beams stuck in infinite cycles, or at least I haven't found whether the input actually does that, because I've kind of cached to make sure I don't get stuck in infinite cycles. But yeah, right, J. So we're going down, up. Okay. And then finally, print max of starts key equals lambda we want to do get num energized of P0, don't think, yeah, okay, P1. That will just give me the best start. Okay, let's see if it actually completes. Okay, got an error. Key error, position row equals 2, column equals 1. Ah, no, these are directions. Whoops. That should be 0, that should be 0, that should be 0, that should be 0. You don't put parameters in the directions. Alright, it's taking a few seconds, but we don't want the max start, we want... Okay, so that's apparently the best starting. We want, just... Alright, let me just, best pos best dir equals max of that, and then just do, print get num energized right. Yeah, it takes a few seconds. Makes sense. It's not that much more, but that sort of makes sense. We might be repeating a lot of cycles that we get in some of the others. All right, 8331. Please, please, please. Yay! I mean, I was confident with that because if the part 1 works, then part 2 will probably work. Ooh, we got some. Ooh, got some movement here. What's that? Lava. Got some lava coming from Lava Island. That's heating up the gears. Springs. We're gonna get some animations in all these islands. Wait, so Gear Island needed the springs to get hot. What was this? This was Desert Island. Needed sand. So maybe we'll get some falling sand. And then Island needed... what, water? We'll find out. Yeah, I needed water, and then the original island, Snow Island, needed the snow machine to work or something. So 16, 4 minutes. Ooh, that's quite a gap. 4 minutes 33, and then 7 minutes 47 and above. So that's pretty good going there. Not easy to code that quickly. See, if you can code the part 1, you shouldn't really need to spend much more time to get part 2 if you're one of these top coders. So I'm actually surprised he spent a whole 2.5 minutes extra to do part 2 here. Because if you've got part 1, you just got to add that for loop, really, to go in all directions, don't you? And then it might take like 5 to 10 seconds to actually run. But I'm pretty sure you could churn that for loop out in like 2 minutes. Faster than 2 minutes. Do they actually get it in 2 minutes? Yeah. They get the answer in. In 2 minutes, yeah, that's what the leaderboard shows. It's not that surprising, to be honest. I've seen videos of these people competing, and they are incredibly fast, and they've got a lot of pre-prepared methods and stuff, so they know. They do this. They enter all the competitions, and they've probably been doing it since they were kids, like entering the Informatics Olympiad, International Informatics Olympiad, which has similar problems. So, yeah, they know what they're doing. But it is quite a gap, though, so... I mean, I need to watch this, people. I don't believe it. Some of these competitors may have actually recorded videos of themselves. Like, you can't... if you're a top coder, you're not allowed to live stream it, but they may have recorded a video and then they might put it up on YouTube. I bet some of them have YouTube channels where you can actually see what they did. But yeah, they're often very, very fast. I mean, yeah, it's a whole big sport, but it's not something I've ever been interested in getting into, because it seems like if you want to be at the top end, you just need a lot of pre-prepared libraries and stuff. So, you know, if it's BFS, you quickly paste in your BFS code that you've used a billion times. That level of preparation doesn't seem fun to me at all, but they enjoy it, so good for them. But yeah. One typo and they're done for. Well, they probably... yeah, I don't know what exactly they would do for this particular problem, but the biggest issue is, of course, translating all the slashes and lines to meaning. Once you've got that, I bet they've probably done problems similar to this in the past, and then they just copy in some code from before. or something like that. Alright, and the other thing is my private leaderboard. Is that. So, got a bunch of people catching up. I see you, Maro, you're pretty well caught up as well. You did the one you were scared of doing, the dynamic programming one. Which, I think as a dynamic programming problem, it wasn't that hard, but as a problem, it was hard. You just had to really identify how to translate it into a dynamic programming problem. And then once you have the phrasing as a dynamic programming problem, it kind of all falls into place from there. But that's always the hardest bit of dynamic programming, just translating it into a recursive formula. But then you just apply the recursive formula with caching and it just kind of just works like magic. And the other one is Captain Coder's leaderboard, which Captain Coder will be streaming at some point today. Maybe even now? No, it's a bit earlier. Probably in a couple of hours. Who is actually doing advent of code? There was a guy I was watching the other day. I don't think he's live now. Who was it? Alka often goes live. Let's see, this guy's using... May I ask how many languages you speak? You mean, like verbal languages? Just English? Properly, just English. I learned a bit of Spanish in school and I can understand a bit of French because my mom lives in France, but I can't hold a conversation in any other language, just English. Hang on, so this guy's doing C++. Alka is doing C# or something. JavaScript.
And change the font.
I don't see many people doing Python, even though Python is probably the most common language in advent of code now. But I don't know if that's actually true. Oh, who's this? Not seen them before. Rust. Yeah, Rust is quite popular too.
Oh, wow, 10 years.
Alright. I guess I'm done. So yeah, my lead. Oh, okay. I'll post my.
Yeah, then you must
Post this in chat just in case anyone
space.
who is in chat wants to join the leaderboard.
Your server is running.
That's just mine, and I also recommend checking out the Captain Coder because he has quite a
On container.
quite a good production quality stream going on every day where he's tackling the problems in C#.
I guess what do you mean by hosting? I'll describe the setup. I have a
Yep, that's it.
I have a Mac Air.
Tell you what, I think I'll probably raid Alka
A,
because
I
I think I watched his
pink
stream.
and blue, and then it's going to be halved pink and blue.
Alright. I need to go and put this video on YouTube and everything. Thanks for watching, and see you tomorrow.